Hello everyone. In this video, we're going to start with Unit 2 from your textbook. So please keep your textbook and a notebook ready so that you can write down the meanings of difficult words that we come across in the lesson. And in case there are any important points, you can actually jot it down. So we'll start with the lesson called the Raman effect, and this is about C.V. Raman. So we're going to learn about C.V. Raman, and we are also going to learn about his discovery. Alright, so just to give you a review of what we did in the previous video that we did was about the difference between discovery and invention. So discovery is something which already existed and that was brought to light by somebody. Alright, so C.V. Raman brought to light the Raman effect, which actually existed, which we were not aware of, and he discovered it and he told the world about the Raman effect. Alright, so if you have your textbook, please open with me to page number 2, where I'm going to start reading the first paragraph for you. The first paragraph on page number 2, which is the Raman effect. In the year 1930, the most unexpected thing happened in the world of science. So science was a very popular researched area at that point of time. And in the year 1930, something very remarkable happened. Now what happened here? It says it was unexpected. People never expected that this would happen in the area of science, and it happened in 1930. A young Indian researcher, Chandrasekhar Venkat Raman, won the Nobel Prize for Physics for his groundbreaking discovery of the phenomenon called the Raman effect. Now, groundbreaking, discovery. So, C.V. Raman, he discovered something, and that was the area where he was given a Nobel Prize in the year 1930. And 1930 is a year that you must remember. That was the year when he was awarded the Nobel Prize, and this Nobel Prize was something which was groundbreaking, which means unique, something which never happened earlier, a unique discovery which was made by C.V. Raman, and this discovery was called the Raman effect. All right. And now coming to C.V. Raman's childhood. Hailing from Tiruchirappalli in Tamil Nadu, Raman completed his early education in Presidency College, Chennai. Presidency College was a very prestigious college in Chennai, and that was where he studied. And then, such was his interest in physics. His father had been a physics teacher. If you remember in my last video, I told you this, right? His interest in physics was because his father was also a physics teacher. That despite clearing the civil service competitive exam and becoming the deputy accountant general in Calcutta, he still found the time to pursue scientific research at the Indian Association for the Cultivation of Sciences. Now, being the Deputy Accountant General, it's a very prestigious position, a position which has a lot of responsibilities, where the person who's in that position has to put in a lot of hard work continually, and even in that busy schedule that C.V. Raman had, he took some time off to study physics. And where did he study physics? At the research center called the Indian Association for Cultivation of Sciences. Alright. Now in the year 1917, he finally gave up his administrative position to become a professor of physics at Calcutta University. In the previous video I was talking to you, right? Clearing the civils examination is a Herculean task, a very difficult task. He cleared it, he got a job for himself, a deputy accountant general, a very prestigious position, and he just gave it up because he wanted to pursue his career in physics. And where did he join? He joined the Calcutta University as a physics professor. Alright, and then by the time he embarked on his first overseas to London as a delegate at the university's Congress in 1921, leading physicists of the time like J.J. Thomson and Lord Rutherford were already acquainted with Raman's significant study in the field of optics and acoustics. Now, by the time he embarked is when you board a ship or a plane, you can use the word embark. So he boarded a ship. And where was he going? He was going to London. He was going to London to what? To do what? He was going as a delegate to attend the Congress, the university's Congress in the year 1921. So in the year 1921, he was going towards London to attend this Congress. And at that time, in the year 1921, J.J. Thomson and Lord Rutherford were very popular, famous scientists. They were renowned scientists in the area of physics. And at that point of time, Raman was studying acoustics and he was optics. Optics, of course, you know what optics are. And acoustics is sound. He wanted to study sound, optics and acoustics. And then Raman had studied classical percussion. Now, what is percussion? Raman was studying classical instruments which worked on percussion. Percussion is, striking it with a stick or with your hand. And what was it he was researching on? The sound, the instruments like the tabla and the mridangam. The tabla, those two pieces of instruments, musical instruments, where you play it with your hands, and the mridangam is where it's a huge one where you play it on the sides. So striking, when there is music coming out of percussion, percussion is striking with your hands or with a stick. That was the area where Raman was researching. So the tabla and the mridangam were his first areas of study. And then, more specifically, the mathematical relationships that produced the pleasing effects of the sound. Now, what was he studying? He was trying to understand, research how these sounds were produced. He was more concerned about the mathematical, replacements there. He was trying to learn more about it. How are these sounds produced? Such a, melodious sound once you play the tabla and the mridangam. So that was his area of study. And this area of optics and acoustics were already being mastered and ruled by J.J. Thomson and Lord Rutherford even before Raman entered this area of study. Alright, so this was in the year 1921. Now these are certain names that you have to keep in mind. J.J. Thomson is one, Lord Rutherford is one. The year 1930 is when he received the Nobel Prize. The year 1921 is when he for the first time embarked the ship to go to London for the university's congress. And 1921 was the year where these two scientists, J.J. Rutherford and Lord Rutherford and J.J. Thomson, were very popular in the area of the study of physics, okay, or the research. So these are a few things that you have to remember. Now go to the next page. We are going to do the next paragraph here. Here it says about, it was during this particular sea voyage to London that he was struck by the blue color of the Mediterranean Sea. Now he embarked on the ship, and even as he was, going towards London, he looked at the sea waters. And what did he see? He saw that, the Mediterranean sea waters were blue in color. Now let me ask you a question. Why are the, waters blue in color? Yeah, we all know a very simple answer for this, that the sky reflects in the waters and so it is blue. The sky is blue and so the reflection in the water looks blue, isn't it? So the color of the water is blue. This was also proved by J.J. Thomson and Lord Rutherford during that time. So he was traveling in a ship and he happened to look at the sea waters and he was wondering, how can the water, color be blue in color? Okay, how can it be blue? And then the next line says, till that time it was generally accepted that the blue color of the sea was actually a reflection of the sky. Isn't it? You know that and even I know that. We think that, that the color of the sea is blue because it's the reflection of the sky in it. And then this was confirmed by the celebrated physicist Lord Rayleigh, who had proposed that the minute particles in the air scattered the blue wavelength from the sun's white rays. So here Lord Rayleigh proved it. He said the minute particles, from the sun, when they get into the waters, they scatter. They scatter, and because they are from the sun above, the color of the sea is blue. Alright, this was confirmed by Lord Rayleigh at that time. And now the next line. Here. However, Raman was not convinced by this explanation. Now, the whole world agreed with Lord Rayleigh's explanation, and they all understood, and it was confirmed that the color of the sea is blue because of the reflection of the sky. But Raman, Sir C.V. Raman, was not happy with this explanation. He was not satisfied with this explanation. And then what happened? He speculated. He speculated means he thought. He thought there's something else. He speculated that the blue color of the sea could be caused by the scattering of sunlight by the water molecules. To verify his speculations, he used a polarized. Now, polarized Nicole prism. Polarized means something which is restricted. Now, Raman was not convinced. He said no. He speculated. He said there was a doubt in Raman. He said this cannot be the reason. So, in order to prove himself right, he wanted to go for a further study and research. So, what did he do for his research? He took a polarized. Polarized is where the direction is restricted, where that item can only go in one direction, that object can go in only one direction. That is polarized. And what is this? Nicole prism. Nicole prism is an object which is used for analysis, examination. So he used a Nicole prism which was polarized, which means the Nicole prism could not go in all the directions. It was restricted to only one direction. This was used for his experiment in this area, where he wanted to prove that there was some other reason behind the waters of the sea being blue and not just the reflection of the sky. Alright, so he started research with the polarized Nicole prism, and then on a sample of seawater to show that light was indeed scattered by the water molecules, a phenomenon that he called molecular diffraction. Now he said light, from the sun, when it fell onto the waters of the sea, yes, they were scattered. They were scattered molecules, and they scattered and went all over the waters. But this was called molecular diffraction. Molecular diffraction, molecular going in different directions. This is molecular diffraction, but not making the colors of the sea blue. This was his explanation. Now next, let's go to the next one. On his return to India, he initiated research in 3 areas. Now these 3 areas of research are very, very important, and also are asked in your you are questioned regarding these 3 areas in your exams too. So you have to remember what these 3 areas here. He went to London, he attended the university's congress, but he came back. He came back into India with one query, one doubt that he had. He wanted to prove that the waters of the sea were not blue because of the reflection of the sky, but there must be something else. So in order to prove this, he started studying 3 different areas. Now what are the areas here? The first one, the scattering of light by liquids, the scattering of X-rays by liquids, and the viscosity of liquids. Now here the meaning of the word viscosity means friction. Okay, viscosity means friction. Now these were the 3 areas. So let me repeat. The first area was the scattering of light by liquids. The second area was the scattering of X-rays by liquids. And the third area was the friction that is caused by liquids. Friction, the word that is used here is viscosity. Alright? Okay. The next slide now. Of these 3, it was the work in the first area that fetched him the Nobel Prize. So the Nobel Prize was based on the first area of his research. Now what is the first area of his research? It is the scattering of light by liquids. When the light scattered in the liquid, in the water, what happened? Now this area of research was successful by C.V. Raman. Alright, and a few of his students who helped him find out this. And this area fetched him the Nobel Prize. Fine. Now let's go to the next slide. Over the next 7 years, which means from 1921 to the next 7 years, what was he doing? Yeah, over the next 7 years, he, along with his distinguished associates such as K.R. Ramanathan. K.R. Ramanathan was his student. He was a student who was doing his research under C.V. Raman. So K.R. Ramanathan and K.S. Krishnan, both of them were his students in research, and they were actually helping him to find out the reason behind the waters being blue. Conducted and supervised many experiments along these lines. On the morning of 28th February 1928, Raman and his associate had irrefutable proof. Irrefutable means something which is impossible to deny. Irrefutable means nobody can argue. Nobody can say you are wrong. So they came up with results which were irrefutable, which means nobody could challenge them. They were 100% right. Nobody could prove their research wrong. They stuck upon this. And when was this? In the year 1928, the 28th of February. They found the results of their experiments. And it was irrefutable. Nobody could say they were wrong. It was impossible to deny the truth. That is irrefutable, right? Irrefutable proof of the uh, modified radiations observed in the scattering experiments due to molecular vibrations. So they understood once the liquids, once the light scattered in the liquids, what happened. Alright, and then the next line says, the discovery was announced through the Associated Press on 29th February and 8th March. Raman sent a detailed note along with an explanation to Nature. Nature is actually a scientific journal. So they found out the reason. The reason is the scattering of molecules in the water. And once I'll repeat the previous sentence, look at that. What was their experiment? It said that they observed that modified radiations in the scattering experiments due to molecular vibrations. The molecules from the sunlight went into the waters and there were molecular vibrations in the sea waters, and that made the color of the sea waters blue. This, what happened is, they spoke about this. When did they speak about this? They spoke about this through the Associated Press on the 28th of February. Okay, on the 28th of February, the 29th of February, they spoke about this to the, to the association. They gave an explanation in a journal called Nature. And then on 8th March, Raman sent a detailed note along with an explanation to Nature. Not just saying, he also sent a detailed explanation why the colors of the water are blue to a journal called Nature. And then the next line, it was with a sense of affirmation. Affirmation means sure. He was sure that this was correct. Affirmation that he addressed the gathering at the South Indian Science Association on 16th March 1928. Now you have to remember certain dates. On the 28th of March 1928, they came up with a positive result for their research. And then on the 29th of February, they told people that they have understood why the color of the waters are blue. And on the 8th March, they wrote to Nature, the journal, to give a proper explanation about the sky, about the sea's waters being blue. And then on the 16th March 1928, with the following words, Raman spoke to an audience of the association. What did he say? I propose to speak to you this evening on a new kind of radiation or light emission from atoms and molecules. By this time, the experiments were replicated and the findings were confirmed, thereby leading Raman to the inevitable Nobel Prize. Now, after he spoke to the audience, he told them that the molecules from the sunlight, they get into the waters, and there is a lot of friction in the waters. Because of this friction, molecular friction, the colors of the water are blue in color. And then Raman had achieved what he had claimed in 1924 at a meeting of the Royal Society of Fellows. He had announced that he would win the Nobel Prize in Physics in the next 5 years. Look at the confidence that Raman had. When was Raman awarded the Nobel Prize? If you remember, we started with this sentence. In the year 1930, he received the Nobel Prize. But look at Raman's confidence. The affirmation, that confirmation that he had on the experiments that they were conducting. In the year 1924 itself, he said, in a few years from now, maybe 4 or 5 years from now, I am going to receive a Nobel Prize. Now, a Nobel Prize is not a small award. A Nobel Prize is something which has status symbol in it, right? Your prestige is involved in it. Now, Raman was putting his prestige at stake by announcing that he will be awarded a Nobel Prize. Now, he needs such a lot of command on the subject, isn't it? Such a lot of surety on the subject that he was researching on, that he announced in 24 itself that he is going to receive a Nobel Prize. Did he receive it? He did it, right? Rightly, as he said, in a few years from now, I'm going to receive a Nobel Prize. And in the year 1930, he was awarded the Nobel Prize for having found out that the waters of the sea are blue in color because of molecular diffraction, molecular vibrations in the liquids. Alright, and the next line. Okay. So, what essentially is the Raman effect? Raman discovered that when a light beam travels through a medium, it is deflected by the molecules in the medium. So, Raman effect is nothing but once the light travels through a beam, it is deflected. It is deflected through molecules. Very interestingly, a small part of the emerging light beam, after being deflected by the molecules, had a different wavelength. So once the molecules were deflected, the wavelength was different. The wavelength became different and the color from the phenomenon. And once the wavelength became different, the color resulted. It became blue in color, right? And then which initiated the study called Raman spectroscopy. Now, other than discovering the Raman effect, he also came up with another discovery, which is Raman spectroscopy, which has to do something with lights, its diffraction, its vibration, and the scattering. So all this with light, right? And then today, Raman spectroscopy finds a lot of applications in various areas, such as the study of molecular structure of compounds. So Raman spectroscopy is used in studying the molecular structure of compounds. It is also used in handheld scanners. You know what are handheld scanners? You know, that huge rod type of thing which people use to scan you when you go to malls, isn't it? You're asked to stand in a a door shaped a frame where you have to stand there, and the security goes up and down with that handheld scanner. That works on Raman spectroscopy. We must have gone to different malls and we must have scanned ourselves, but then we didn't know this. So Raman spectroscopy is used there. Through the light beam that comes out of that hand scanner, they can actually detect if you're carrying anything which is dangerous, any dangerous weapons or something which is dangerous. If it is on you, it scans it. And Raman spectroscopy is used in it. So next time when you go to a mall, remember that it is Raman who has done it. Alright? And then for detecting drugs and explosives. As I said, if you're carrying drugs or explosives on yourself, this handheld scanner detects it. And then the pharmaceutical industry and medical diagnostics. So Raman spectroscopy is not just used in handheld scanners. Even the pharmaceutical industry uses it, and it is also used in diagnosis of various diseases. They are scanned, isn't it? The scanning that is done, usually how is the diagnosis done? Either it is through a blood test or through a scan. And in case you want a detailed report of what you are suffering from or what is going on in your body, you are scanned, isn't it? Whether it's a body scan, a head scan, or a particular organ that has to be scanned, Raman spectroscopy is used in scanning as well. So this is Raman's discovery, alright, the Raman effect, and which is also used in the Raman spectroscopy. So a very quick review of what we spoke so far. This brings us to the end of the lesson. This is a very short lesson. See, if you see this is the end of the lesson. So let's just begin with what we were speaking about. The lesson started with Raman receiving the Nobel Prize in the year 1930. And then Raman, as I already told you, hails from a small town called Tiruchirappalli, which is in Tamil Nadu. And Raman, he studied in Presidency College, a very prestigious college at that point of time. And then he studied in this college and he cleared his, civils examination, which is a very tough job. I told you, right? It's very tough to clear the civils examination. He cleared it, and then he qualified and he became the Deputy Accountant General in Calcutta. That was a government and a very prestigious position. He had a lot of responsibility on his shoulders, but then even after having so much of responsibility on his shoulders, he took some time to spend in the research center to study physics because he was passionate about physics. And as I told you, his passion for physics actually came from his father, who was also a physics teacher. So looking at his father's teaching physics and reading all the books that his father had at home, he developed this interest for physics, and this continued even after he got a government job. Usually people settle down, a government job, now my life is settled. But he did not settle down because he wanted to pursue his career in physics. And so he started studying and researching on physics even as he was working. And what he understood was he was not able to give enough time to the area of physics, and so he gave up this job. He gave up this job and he started pursuing his career in physics. And then after giving up his job, he started doing his research on optics and acoustics. And as I said, when he started research, J.J. Thomson and Lord Rutherford were very popular in the area of physics. But he studied, the first area of his research was optics and acoustics, where he studied the tabla and the mridanga. And that was the time when he embarked to London. And when he was going to London, something very exemplary happened with C.V. Raman. He noticed that the waters were blue in color, and the explanation that was given at that point of time was by Lord Rayleigh, who confirmed that it is the reflection of the sky which is in the waters and it is making it blue. But then, as I told, Raman was not satisfied with this, with this explanation. He further studied why was the color of the water blue, and he understood that it was molecular diffraction. He understood that it was molecules which vibrated once they entered the waters, and this vibrations brought about the color which is blue. And he spoke about this, he gave an explanation about this, and he submitted it to a journal called Nature. This was found in the year 1928, but in 1924 itself, Raman declared that in a few years from now he is going to receive a Nobel Prize, and this was the area where he received the Nobel Prize. At the same time, he also came up with Raman spectroscopy, and Raman spectroscopy is also talking about diffraction of lights. As I said, spectroscopy, Raman spectroscopy is used in those handheld scanners where people are scanned before entering a mall. So that is the Raman spectroscopy. It works on Raman spectroscopy, where it can be detected if you are carrying explosives or any drugs on you. So Raman spectroscopy is used in handheld scanners and also in pharmaceutical industries. And not to forget, scanning. It is also used to diagnose if you are suffering from any diseases. So Raman's effect and Raman spectroscopy are two important points that you have to keep in mind. And even as you are studying, there are 3 or 4 questions which I have already mentioned to you which are important. The year 1930, the 3 areas where Raman researched, when did he talk about Raman spectroscopy, J.J. Thomson and Lord Rutherford and Lord Rayleigh. You have to remember all these points, and when you are able, and that is the time when you will be able to answer any question that comes from the unit, the Raman effect. We will continue in the next video with the grammar exercises after unit 2. Thank you so much.